Today in our chapter ray optics and optical instrument, now to see one numerical. Numerical is based on the refraction of a light from the spherical surface. The formula is here n2 upon v minus n1 upon u is equal to n2 minus n1 upon r. Using this formula we to solve this numerical. The numerical is like this way, just you can see here. Light from a point source in air falls on a spherical glass surface n is equal to 1.5 and radius of curvature is 20 centimeter. The distance of the light source from the glass surface is 100 centimeter. What is the position the image is formed? Again, the light from the point source in air falls on a spherical glass surface n is equal to 1.5 and radius of curvature r is equal to 20 centimeter. The distance of light source from the glass surface is 100 centimeter. What is the position the image? What position the image is formed? Now you can see here, suppose this is a spherical surface and suppose here the light from the point source, suppose here it is, that is O, incident on this surface, and this is the and refracted on this medium, and image is formed here, that is I. Now here perpendicular bisector is drawn here. This is a perpendicular bisector, that is C, that is known as radius of curvature R. Half of this is focal point. Now this object is kept at u, that is u distance from here, and image is formed here, that is v distance from the spherical surface. Now refractive index of this is n1, this is n2. n1 is equal to 1, n2 is equal to 1.5. now distance of the object, that is u, is equal to, now in the direction of, we can take the distance against the direction of ray, so finally we can get here minus 100 centimeter. This is in the direction, so we can find out that is v here. R is taken as in the direction of ray, this R is equal to 20 centimeter. Now we can use the formula here, that is n2 upon v minus n1 upon u is equal to n2 minus n1 upon r. Therefore n2 is 1.5 upon v minus 1 upon minus 100 is equal to 1.5 minus 1 upon 20. Therefore 1.5 upon v plus 1 upon 100 is equal to 0.5 upon 20. Therefore 1.5 upon v is equal to 5 4 ja, so we can get here 1 upon 40 minus 1 upon 100. Now we have to take the LCM, so we get here 1.5 upon v is equal to 100 minus 40 divided by 40 into 100. So we can get here 1.5 upon v is equal to 60 upon 40 into 100. Now simplifying, we to get here v upon 1.5 is equal to 40 into 100 upon 60 Now to solve here, we can get V is equal to 40 into 100 into 1.5 upon 60. This 0 will be cancelled, so this 4 will cancel, is equal to 100 centimeter plus 100 centimeter. It means that the direction of the image distance in the direction of the ray, so that is taken as positive, so 100 centimeter. So this way to understand this numerical. In this numerical, the formula for the refracting spherical surface, that is n2 upon v minus n1 upon u is equal to n2 minus n1 upon r. You can take the here sign convention, that is in the direction of ray taken as positive, against that is taken as negative. So here u is equal to minus 100 centimeter, r is equal to 20, n1 is equal to 1 and n2 is equal to 1.5. Keeping this value in the equation, that is n2 upon v minus n1 upon u is equal to n2 minus n1 upon r. Therefore 1.5 upon 100, therefore 1.5 upon v minus 1 upon minus 100 is equal to 1.5 minus 1 upon 20. Simplifying, and finally we can get here v is equal to plus 100 centimeter. Plus indicate that plus 100 centimeter indicate that the distance is taken in the direction of ray, and image is formed at 100 centimeter on the principal axis. So this way to understand this. Numerical. Thank you very much.